Hi everyone, today I'm going to share a question on BPhO 2024, Section 1. So this is a question that I failed to finish in the competition in 2024. Yeah, so now let's talk about this question. So it says a cone of circular cross-section sits in the liquid of density L with its apex pointing down and its base level with the surface of the liquid. Like this, surface level is here. Okay, so the density of the cone varies linearly along its length. The rho is varying. The base of the cone has a density of rho b, half of that of the liquid, so 1/2 rho L. So what is the ratio of the density of the apex? So the apex has the density of rho. So how to do this question? The total thought about this question is to have the relationship by using this sentence. It is the key. So what does it mean by this sentence? It says from the knowledge of buoyancy, we can know that if the object is floating like this, the density of the object should be equals to the liquid. Let's say the average density, because the density of this object is actually varying. So now we have to calculate this density. Okay, so another thought about this floating like this is like if the total cone is filled with water, the mass should be equal to the actual mass of the cone. So let's use this formula to calculate out this question. So if the cone is filled with water, the mass should be 1/3 pi h. Let's say this height is big H and this angle is theta. So it should be big H times H tangent theta squared. Yeah, it's like this. So why it's like this, like tangent theta, by using this geometric relationship, it is H tangent theta. Okay, so the critical point is to find the actual mass of the cone. So what is it? Another key sentence is that the density of the cone varies linearly along its length. So by this, we can using integration to find the final answer. We can slice the cone into small cylinders like this. Okay, it's a bad drawing, but anyway. Because over a small length, we can assume that the density doesn't change. So dm equals to rho dv. We should always slice the objects in the direction of varying. Yes. So first, let's find out what is dv. dv is the volume of the small cylinder. It is pi r squared dh. So r, similar with calculating the big R here, the R here is small h times tangent theta dh. We call the distance between the point we calculate and the apex is H. So now dv, we succeeded to calculate out. So what is rho? We should use this linear relationship. So rho can be written into the form of KH plus B. So this is the linear relationship. So what is K? So the density varies from rho A to rho B, and the distance of big H. So the gradient should be rho B minus rho A over the big H. So what is B? So B, from the line, if you see maybe this or this, the starting. So this one, B, should be the initial row of this cone. So because we integrate from the apex to the base, so the initial one is rho A. So rho can be written into the form of rho B minus rho A over big H multiplied by small h plus rho A. So this is rho. Now we can write out dm. So dm is this stuff multiplied by this stuff. Okay, so now let's do the integration. So m equals to 0 to h we can separate it into two terms, like which is easier for integration. 0 to h, and the second part is rho A Okay, so now let's pull out all of the constants for each term. Tangent theta squared, h squared dh, 0 to big H, and zero to h squared dh. So because if it is integrate out, it should be like 1 over 4 h to the power 4, and integrate from 0 to h, and plug in 0 to h, it is like this, and it is 1 over 4h, big H to the power 4. And similarly for the second term, it is 1 over 3h cubic. So let's arrange these terms, and we can get the final answer of pi tangent theta squared h cubic 1 over 4 rho b plus 1 over 12 rho a. So now we get the mass of the terms, the actual mass. So now let's use this relationship to find out the rho A, because the only unknown term in this relationship is rho A. So we can find out it. So now let's do this. This equals to so 1 over 4 rho B equal plus 1 over 12 rho A equals to 1 over 3 rho L, because these terms can cancel out. Because rho B equals to 1 over 2 rho L, so rho A actually equals to 5 over 2 rho L. So this is the answer, and I think the official answer given by the BPhO website is 524, and I think it's have calculated the wrong answer. So yeah, this is this question, and thank you very